Good morning, boys. I am your chemistry lecturer Subroto. Today we talk about chapter 8, Chemistry and Energy. It's our last lecture. Okay, we go to the class. First, we talk about electrochemical cell. Which is two types. One is electrolytic cell and another is galvanic cell. Okay, first we talk about electrolytic cell. Electrolytic cell is that cell where electricity is used to continue a reaction. A electrolytic cell is, we draw here, its anode, its cathode. Here electrolyte, and it's a battery. Okay, now we talk about electrolysis of sodium chloride solution. Okay, it's an example of electrolytic cell. Electrolysis of sodium chloride solution. Okay, in sodium chloride solution there is two compound. One is sodium chloride in aqueous form. It will convert to sodium ion aqueous plus chloride ion aqueous, and water H2O, which will convert it to H plus ion and hydroxide ion. We have to know that here two positive ion, sodium ion and H plus ion, and two negative ion, one is chloride ion and another is hydroxide ion. This sodium ion or hydroxide ion will take or receive electron to produce a atom or molecule, and this chloride or hydroxide will donate electron, and this chloride and hydroxide will form water or chlorine gas. Okay, but we have to know that which one will receive or which one will donates electron. From the series of activity, we know that the reduction potential of hydrogen is more compared to sodium. That's why it will take electron from the cell or battery, and the amount of chlorine is high compared to hydroxide ion. That's why it will donate electron and it will produce chlorine. Okay, then anodic reaction. In anode, oxidation is occur. That means chloride will donate electron and produce chlorine atom, and this chlorine atom will attach with another chlorine atom and it will produce chlorine gas. In cathode reaction, hydrogen will take one electron and produce hydrogen atom, and this hydrogen atom will attach with another hydrogen atom and it will produce hydrogen gas. Now we draw a picture of this electrochemical cell. It is the picture of this electrochemical cell. electrolytic cell. Just simple picture of this. You should go through the your book where you get the main picture. Is anode where chloride will go and chlorine gas is produced. In cathode where hydrogen gas is produced, and here sodium hydroxide in the solution. Sodium chloride electrolysis of sodium chloride. Okay, we think that it will get my point. Okay, then we'll talk about the electrolysis of molten sodium chloride. In molten sodium chloride, only sodium chloride are there in liquid form, and it will produce Na plus and Cl minus. Okay, by electrolysis this sodium ion will receive an electron and it will produce sodium solid, and this chloride ion will donate electron and it will produce chlorine atom, and chlorine will attach with another chlorine atom and it will produce chlorine gas. Okay, it is the electrolysis of molten sodium chloride. If we want to draw the picture, here only erase the water molecule and then we'll get the picture of molten sodium chloride, electrolysis of sodium chloride molten. Okay, then we talk about the electrolysis or galvanic cell. We will talk about galvanic cell. In galvanic cell, two electrodes are used as electrode, where one is anode and another is cathode. In anode the oxidation is occurred, and in cathode reduction is occurred. We use zinc and copper as anode and cathode. First we draw the picture of galvanic cell. Here we use the short bridge. It is a simple form of galvanic cell. It is in my left side there is it is the electrode which is known as anode, and in my right side it is cathode. It is zinc electrode and it is copper electrode, and we use zinc sulfate as electrolyte in zinc electrode and copper sulfate in cathode. It is the light where electron pass through here to here, electron, and electricity pass from right to left. Okay, and in anode zinc will donate 2 electron and it will produce zinc 2 ion, and in cathode copper 2 ion will receive this 2 electron and produce copper solid or copper metal. and zinc is correct, and this zinc will maybe it can lower in size, and the copper is higher or bigger in size. And what is the reason we use this salt bridge? Salt bridge is used to balance the positive and negative ion in this solution. If the reaction is continue, then here the positive ion is lower and higher, and the negative ion is higher in this uh, pan or in this electrode. That's why to balance the ion positive and negative, we use this salt bridge. Salt bridge is more important for this reaction or continue this electricity. If we don't use this salt bridge at a time, the reaction is stopped. That's why you use salt bridge. We have to know the uh, necessity of salt bridge in details. Okay, thank you. Okay, maybe we can understand the reaction of galvanic cell. Now we talk about the electrolysis of water. Electrolysis of water. When we use water for electrolysis, we should add a small amount of acid to dissociate it. In aqueous form, it will produce H plus and OH minus. Okay. Then in cathode, we use the cathode. We use the cathodic reaction first, because to balance the reaction. Okay. CH reaction. Hydroxide will donate electron. Okay, we have to know that the hydroxide, if the hydroxide donates electron, it will produce water and oxygen. We have to memorize it that hydroxide will produce water and oxygen. That means if we use this reaction, we have to memorize that the hydroxide will form water and oxygen. That means here we have to balance this reaction. Here we have 2 atoms of hydrogen and 3 atoms of oxygen. If you want to balance, we have to multiply it by 2, and here the amount of hydrogen is 4 atom, and amount of oxygen is 4 atom. That means we have to multiply it by 4. Okay, that means 4 hydroxide ion will produce 2 molecule of water and 1 molecule of oxygen, and 4 hydroxide will donate 4 electron. Okay, we need 4 hydroxide ion, and 4 hydroxide will produce from 4 water molecule. That means 4 water molecule will produce 4 hydroxide and 4 H plus ion. Okay. Anodic reaction, the 4H plus will receive 4 electron and it will produce 2 molecule of hydrogen. It is the reaction of this electrolysis. We have to memorize it. If we can memorize this reaction, or we can understand this reaction, in exam we can write it very carefully or very properly. Okay, the total reaction is 4H2O will produce 4H plus 4 hydroxide, and that H plus and hydroxide will produce 2 molecule of water, 1 molecule of hydrogen, and 1 molecule of oxygen and 2 molecule of hydrogen. And if we balance this, 4 to 2H2O is equal to 2H2. Okay. Okay. Okay, again we talk about dry cell. Uh, Here we draw the picture of dry cell. Here anode is zinc and the cathode is used as carbon electrode. It's a carbon electrode, and here we use a paste of ammonium chloride, manganese oxide, and so on. The reaction of dry cell are given here. Anode, zinc will donate 2 electron and it will produce zinc 2 ion, and in cathode ammonium ion plus manganese dioxide plus 2 electron will produce ammonia plus manganese oxide. It is manganic oxide and it is manganese oxide plus water 2 2 2. Okay, it is the reaction of dry cell. We have to memorize it very carefully that we can use this reaction or use this in our khata. Okay, now we talk about the nuclear reaction. Nuclear reaction is that reaction where energy is produced by reaction of something where a molecule or a particular molecule is converted to another particular molecule. That means if we have uranium, we can get krypton and barium. Okay, we get krypton and barium, which is more about different thing. That means is a particular compound or molecule which is uranium, and we'll get krypton and barium which is another molecule. It's a different type of reaction. Okay, now we talk about the types of nuclear reaction. One is nuclear fission reaction and another is nuclear fusion reaction. In nuclear fission reaction, a big molecule or big atom will convert to a small molecule and it will produce huge amount of energy. The reaction of nuclear fission reaction are given below. Here uranium 235 and 92 plus a neutron attached with a neutron, or speed of neutron will break this uranium and it is produced barium plus krypton plus neutron, 3 molecule of neutron and huge amount of energy. The 56, 92 and 36. Okay, if we want to memorize it, we have to know a rule: an be kere 3n. If we memorize this, then it will 92. Okay, an be kere 3n. If by this we can memorize this reaction. And in fusion reaction, a small molecule or a small atom will produce big atom and release huge amount of energy. The reaction are given below. Hydrogen, isotope of hydrogen 1 1 2 1. Okay, will produce helium 42. Okay, we use here 2 molecule of hydrogen and huge amount of energy. If we write it as exact as the book, then we use this: hydrogen plus helium 4 to 1 neutron plus energy. It's energy, huge amount of energy. Okay, this is our last topic of this chapter. We have to memorize all the topic and memorize it, or go through or read from our test paper, solve some question of this chapter, of this test paper. We have to solve some MCQ problem from this chapter. It's an important chapter for your HSC exam, SSC exam, because one set of questions are almost every year comes from this chapter. Thank you. Stay home and be safe. Thank you.